What I've done in this code file here is compile a bunch of types of errors that I often have encountered in my own coding and in the coding of my students over the years. Now, this, of course, is not an exclusive list. It doesn't mean that all possible errors are going to be present here, but these are the kinds of errors that you can start thinking about to look out for. Now, if you haven't already, I encourage you to pause the video, go through this code file, and see if you can fix all of the errors in this code file. Now, in some cases, it's relatively easy, also because I give helpful comments here. Sometimes it's a little bit more ambiguous, and sometimes it's not really clear how, what is the correct way to fix the bug, because we don't really know what the goal of the code is. But anyway, see if you can work through all of the errors and get these things to work. Okay, so this is a really common type of error, a spelling mistake. So here I have a variable that is called variable, BLE, and here it's spelled wrong. So now Matlab is saying unrecognized function or variable, variable, misspelled. You would be surprised, you would be shocked how often I get frantic emails from students saying, oh my God, my code doesn't work. I'm a terrible programmer. What's going wrong? Nothing works. Everything is broken. My life is ending. And it turns out that one variable is misspelled somewhere in the code. So always be mindful of spelling mistakes. Now, one thing that's pretty useful actually in MATLAB is if you click on a variable, if that variable appears more than once in your code, MATLAB will color all instances of that variable. So you don't see that happening here. But if I were to write variable, now it's spelled correctly, now you can see when I click on one of these instances, all the other ones get highlighted. In my case, it's purple because that's how I set up my colors, but it might be a different color on your screen. And you can also see, so this might be too small to see on your screen, but you will see it on your own computer when using MATLAB. As soon as you click on this variable, all the other instances of that variable are highlighted here with a purple thin horizontal line. So you can find all these other instances really easily. So now this also shows you very clearly that this variable is spelled differently. All right, so that's this error. Here we have an incomplete line of code. These kinds of errors I don't see too often because I think they are really easy to spot. It's really easy to notice when you have this kind of error. So yeah, I mean, this is a case where we don't really know what's the right answer here. So I'll just say for I equals 1 through 10, and then we display that number. So the next type of error message that I often see, or coding bug that I often see, is invalid indexing. And I showed you an example of this in the previous video. So let's just run all this code and then see what happens. Well, not surprising, we get an error message. It says index exceeds the number of array elements, which is 12. So clearly there's something going on with indexing here. Now, we can start by figuring out where this code comes from, right? So we get an error message, and the error is somewhere on these 5 lines of code, although it's actually most likely to be either this line or this line. So let's try running this part of code, and that part runs fine. We can even see what this is. I think I'll even plot this. So I'm going to say plot data vec, and you can see it's linearly spaced numbers that go from 1 through 50 times some random number. So here is the linearly spaced numbers going up, and you can see it ends around 50. And it's not a perfect line because we are multiplying, element-wise multiplying by random numbers. So that's fine. And now we can run for I equals 1. So I'm going to set this looping index to be 1. And then run this line. Now I kind of expect that this is going to produce an error, but in fact it doesn't produce an error. So why did we get an error message when we ran all of the code like this? You can even reproduce this. So here we get an error message, but when I run, when I set the looping index to be 1, and I run all the individual lines of code, we actually don't get an error. Now let's try this again. So here I is equal to 1. Now I'm going to run through this for loop, and now we can see I is equal to 13. So this tells us that this loop ran completely fine. Nothing was wrong with this loop for the first 12 iterations. And then we get to the 13th iteration, and now we are getting an error. And that is the key insight to figuring out that problem. So this is an indexing problem. So it's going to be basically on this line. So here we are trying to access the 13th element of a 12 element vector. So that's the problem. And the solution here actually, well, this is where the problem manifests. The real problem, the real source of the error here is actually coming from this line, from this looping statement. And in fact, what we are doing is hard coding to 15. Now maybe in an earlier version of the code, it looked like this, and then this would have worked. But now we have this set to be 12. This is hard coded to be 15. Hard coding is a major source of problems. So what I'm going to do is soft code this by setting this to be n, and then that's going to work. And we can see I equals 12, which is the same as the length of data vec. Okay, and then we can plot this just out of curiosity. New vec, so it's, I don't even know what this is supposed to mean, but it's just numbers that are kind of getting increasing in variance over time, or whatever this x-axis is. All right, so that was a nice little example of finding, inspecting, and plotting in order to fix a bug in the code. Okay, so here we have a dimension mismatch. Again, let's just run this code and see what happens. Okay, so this says unable to perform assignment because the size of the left side, and Matlab is referring here to the left side of the equation. So it's either this one or this one. The left side of the equation is 10 by 2, but the right side of the equation is 10 by 3. So we can also confirm this. So you can see this is a super helpful error message. This really tells us exactly what the problem is. So I can copy and then look at the size, and sure enough, this is 10 by 2, and this is 10 by 3. Now, the total size of dat1 is 30 by 3. So in fact, there are two ways to solve to get rid of this bug here. We could make this 1 to 3 like this, and then it's going to work, because then the left-hand side of the equation is the same size as the right-hand side of the equation. Or we could set this to 10 by 2 on the right-hand side, and that's also going to work. Again, this is one of those cases that, I don't know what the right answer is because I don't know what the goal of the code is. But of course, the goal of this video is to find and fix these bugs and to see what kinds of errors are often made. All right, I hope you're enjoying this. I have a lot of fun doing this stuff. Okay, so incorrect function inputs and outputs. So let's try running this code. I'll run this just one line at a time. So it looks like we're trying to make an image of this random numbers matrix. So we get an error, and it says incorrect number of arguments. And now, unfortunately, this one is not as helpful as the previous error message, but this one is pretty helpful. So this says incorrect number of arguments. So we can actually open up this file image.sc. And unfortunately, this is also not giving us such a helpful information. In fact, basically this just says to check out the function image. And it turns out that image.sc is basically the same function as image, but image.sc just adds an extra step to do color scaling. Okay, so now I'm going to open up the file image. Of course, you could also type help image or doc image. And let's see. So we can input a single matrix, or there's a lot of text here, or we can provide three inputs, so X, Y, and C. And that's really the key insight here. So we're not allowed to input just 2 inputs. We have to input 1 or 3 inputs. So 1 to 100, and I know that this is a 100 by 100 matrix, so I'm just going to write 1 to 100 again. And that gives us our resulting random numbers matrix. In fact, it also, another decent solution here would be just to get rid of that first input altogether and just have the color values. Okay, Here we go. The worst, most dangerous, and hardest to find bugs. That sounds really serious. All right, so let's run through this loop. So it actually turns out that there's nothing wrong with this code right here that I've selected and just highlighted. In fact, the only reason why I have all of this code is to create a looping index I. So I want I to be equal to anything. It can be equal to any real valued number. In this case, it's this looping index. It ends up being 4 in the end. The real error is happening down here. I'm creating something called a complex sine wave. A complex sine wave is like a sine wave. You probably recognize 2 pi t. And then to make this a complex valued sine wave, we embed this sine function, so 2 pi ft, inside something called Euler's formula, which is e to the ik. And so here you see e to the, so this is the natural exponential, e to the, and then all of this is in the power of the exponential. So e to the ik, where k is this sine function. Okay, so that's all fine. So now I want to, let's see, this is, I'm not sure why this is commented out, to be honest. Okay, so let's just run this code here. So I want to plot the real part of this sine wave. Now, without even knowing so much about what this function should look like, I'm telling you that it's a sine wave. You can see in the comments that it's a sine wave, so you probably expect this to look like a sine wave. Of course, a sine wave is like this wiggly thing that goes up and down over time. Now, here's a question. Does this thing look like a sine wave to you? It definitely does not look like a sine wave to me. And look at this scale. This goes up to 10 to the 21. This is really crazy. Okay, so what is the problem here? The problem here is that we are supposed to be using the imaginary operator I, but instead, which is equal to the square root of -1. But instead, this is a real valued number because we were using it earlier in the code as a looping index up here. So this is wrong, even though so this is like a math error, not a coding error. Okay, so there's a couple of ways that you could solve this. One is to explicitly clear I, because clear the variable I, and that will return I to its default value of this complex number, 0, the real part, and 1 on the imaginary part. So this is just the imaginary operator I. And then we can try this again. So now, let's see, run this. Notice this is exactly the same line of code as we have up here, except now, do I have code for, yeah, I have code for this. Let's see here. So now I'm going to plot this, and this looks much better, don't you think? This is exactly what a sine wave should look like, and you can see also the amplitude values are what you would expect. And this all happened not because we made a coding error, but because we made a math error with, in particular in this case, with the reserved variable I, which is possible to overwrite in Matlab by creating a variable for it. Okay, so one way to solve this would be to explicitly clear I. However, that is actually not the best way to go about this. The best way to go about this is to avoid using the variable I altogether for the imaginary operator. Instead, you can use 1i. And the reason why, so the number 1i, the reason why this is a better choice is that, remember that I told you with the section on variables, I had a video about variable naming strategy. It is not possible. Matlab will not allow you to create variables whose names start with numbers. So if we try to set 1i to be a number, Matlab is going to give an error. So it is not possible to set 1i to be equal to a number. Which is different from I. We can set I to be any other number. Okay, so this would be a much better strategy, and then that still gives us the correct answer. All right. So a couple of additional examples. These ones are also insidious, potentially difficult problems because, Matlab is mostly internally consistent across different versions over time. So in almost everything that you will do in Matlab, it's basically the same functionality across different versions of Matlab, but there are some exceptions, and some linear algebra implementations are an example. So here what I'm doing is data vec. So I'm trying to create linearly increasing numbers from 1 to 50 at times random, some random noise. Notice this is pretty much exactly what we were doing in the very top of the script, in the very beginning of the script. So let me just run this code here. Now I expect that data vec is a vector. I'm calling it a vector. This is a vector. Here linspace produces a vector, and rand_n produces a vector because we have n comma 1. So a vector, I expect this to be a vector. However, if we look at data vec, you can see it's actually a matrix. It is a 12 by 12 matrix. I can show that by dumping it out on the command window. I can show that by making an image of this thing. Now, that might be surprising. Why is this a matrix when we are multiplying two vectors? Well, if you are comfortable with linear algebra, you might recognize this as something called the outer product. So we are computing the outer product here because these two vectors have different orientations. Now, this line of code is actually version dependent. So earlier versions of Matlab are going to give you an error on this line of code, and later versions of Matlab will produce the outer product. Now, whether you intended to get the outer product or a vector with element-wise multiplication is, it's up to you. It depends on the application. But this is just an example of how things can get weird without being an explicit MATLAB coding error. So one way we could fix this is by changing the orientation of these two vectors so that they are consistent. So now we get a vector instead of a matrix. And all I did was change this. So now these are both row vectors. And so a row vector element-wise multiplying a row vector is still going to be another row vector. Okay, so let's see. Then we have, this is basically one kind of example separated into multiple lines. So here I'm creating this really huge matrix. It's a this is a 1, 2, 3, 4, 5, 6-dimensional matrix. This is starting to get really big. So if I type who's randmat, it doesn't even print out the entire size. That's how big this thing is. It just says 6-dimensional, and here you can see when I roll over the variable name, it says 6-dimensional. So if you want to see all the number of elements on all sizes, you have to say size randmat, and then we get all of the sizes of the individual elements. So let's see how many elements there are in total. You might remember there's a function called numl randmat. So even though every individual dimension of this matrix has only a few elements in it, the largest dimension is 7, because there's so many, in total there's almost 10,000 numbers packed into this matrix. Okay, so we can use linear indexing, which I've mentioned before. Linear indexing is legal in MATLAB, but it's difficult to interpret, and that's because this is some random number, but where in this matrix is the 7,000th element? Which element is it here and here and here and here? What is the coordinate inside this matrix of the linear element number 7,000? So you can imagine that this gets really confusing. So definitely a situation that you want to avoid. Here is another legal way to index matrices, but an even worse idea, and that is to refer only to some elements while linearly indexing some other dimensions. So notice this is a 6-dimensional matrix, and here we have the second element of dimension 1, the fourth element of dimension 2, the second element of dimension 3, and then we just go to, it looks like it's just the fourth dimension, and then it's elements 2 through 57. Again, this is legal. We get a bunch of answers here, but it's hard to know. Okay, so actually, in this case, MATLAB is printing these out. But if we would concatenate all these into a single vector, then it wouldn't really be possible to know where exactly these elements are coming from. So you can also see MATLAB is just telling us this is the 56th element along the linearized fourth dimension. I literally have no idea where that's coming from. Okay, where in the matrix that's coming from. Okay, so the best approach, the best way to index different elements in a matrix is if you have an n-dimensional matrix, then you should have n commas. That's the way that you, or n minus 1 commas. That's the way that you can be certain that you are using matrix indexing in a way that is sensible and easy to follow. So we have a 6-dimensional matrix. So we want 6 sets of coordinates in here. So that means we should have 5 commas. So 1, 2, 3, 4, 5 commas. Now this is just a single number. Of course, you can still access multiple elements in here. So we can say, you know, in the first dimension, let's go the first to the second element. And here we do 6 through 7 and so on. So, you know, you can still do something like this. That's going to return basically a 2x2 submatrix from this larger matrix. All right, and so that concludes this video. I hope you enjoyed it. I hope you found it insightful, and I hope you feel like you have a pretty decent grasp now of the different kinds of mistakes that are commonly made in MATLAB.